Friction, we talk about it whenever we try to move two surfaces against each other. Whenever we have two surfaces against each other and we try to rub them off each other or move them relative to each other, we have friction. Friction plays a very important role. For example, without friction, you cannot hold anything in your hands. It is static friction that allows you to hold that object in your hands. If that object slips and falls, that's because there was not enough static friction, and while it is slipping, we have kinetic friction. We'll talk about that more in a little bit. So the surfaces in these cases are your fingers and whatever you are trying to hold. Now, if we try to push a large piece of furniture and it does not move anywhere, it does not move anywhere because friction is going to balance out your push. If it slides anyway, then friction is going to balance out only part of your push, but then we still have friction. The commercials nowadays with the car insurance company, where we have different objects forgotten on top of a moving car, without friction between the bottom of that object and the top of the car, that object would not stay on top of the car. It is friction that allows that object to move along. Now, we talk of two types of friction, what we call static friction and kinetic friction. The word static means no motion. For example, you have static electricity when you get your clothes out of the dryer. Why do we call it static electricity? That's because the charges are stuck to your clothes there. They are not moving. That's why we call it static electricity. And here we use the word for static friction. The word kinetic is the opposite. We use the word kinetic whenever we talk of motion. So whenever both surfaces are going to be able to move relative to each other, that's when we have kinetic friction. So static friction, when the surfaces are stuck to each other. When you are trying to push a cabinet, heavy cabinet, and it does not move. That's when we have static friction. They don't slide, they don't slip relative to each other. That's static friction. Again, crate, for example, that is not sliding while sitting on the bed of the moving truck. Now, the truck is moving, sure, but what matters is the surface, the bottom surface of the crate and the top surface of the bed of the truck. Since there is no motion of the bottom surface of the crate relative to the top surface of the bed of the truck, since they don't slide relative to each other, since they are stuck on top of each other, we have static friction. When you walk, for example, when you walk without slipping, as you push against the floor, it is the static friction between the bottom of your shoes and the floor that prevent you from slipping and allows you to walk forward. That's static friction. Now, kinetic friction, that's when the surfaces are going to slide relative to each other. Now, think of a box. If I have a box here on top of my desk and I kick it, it's going to start with a certain amount of kinetic energy that I gave it with a kick, and it's going to slowly come to a stop. Why does it come to a stop? Because of friction between the bottom of that box and the top of my desk. That's kinetic friction, since the box was sliding relative to the top of the desk. Now, here, when we talk about the crate on top of the bed of a truck, if we slam the brakes on that truck, that crate might slide forward. Now, while it is sliding forward, it is being slowed down by kinetic friction. Also, we have kinetic friction whenever we skate or if we slip while walking. What's interesting there are only two factors that affect friction. The first is the makeup of both surfaces. What are they made up of? Is it rubber over asphalt? Is it wood over wood? Is it glass over granite? The type of material as well as the textures. Are they soft? Are they smooth? Are they rough? That plays a role in determining friction. The other type of friction, the other factor that affects friction is how hard the surfaces push against each other. If we think of the example of the box that I kicked on top of my desk, now if I fill that box with something so it is heavier, then it's going to push harder against the desk, and the friction force is going to be more in that case. So the more the surfaces push against each other, the larger the friction force. That's a direct relationship. Now, factors that do not affect friction, they are counterintuitive in this case. One might think that the size of the surfaces, the bottom, for example, the size of the bottom of my box on top of my desk, one might think that's going to play a role. Actually, it does not. One might think that the width of the tires in a car play a role in the friction. No, they don't. Actually, the tires of a car involve much more than just friction. They involve heat, they involve friction, they involve allowing water not to collect under the car, under the tire. So it's something beyond the scope of what we are talking about here. But one thing to remember, the size of the tire is not going to affect friction. It will affect other things, but not friction. Also, the speed of the surfaces relative to each other. One thinks if I push my box with a slow speed, it's going to experience a different amount of friction if I get it to move faster over my desk. No, friction is not affected by speed. Another type of friction that's often talked about is air resistance. That's, for example, what a parachute experiences while it is falling down. Without air resistance slowing it down, the person is going to hit the ground with a high speed. Also, whenever you rode a bicycle or whenever you got your face out of the window of your car, or whenever you rode a motorcycle, you have experienced air resistance. Now, air resistance, though, even though we are calling it here friction, it's very different from what we just talked about. Air resistance depends on the size of the surfaces. Actually, the surface that's facing the wind, that's going to play a big role in air resistance. Moreover, the shape of the object is going to affect air resistance. That's why car manufacturers, airplane manufacturers are always working very hard to make the shapes of their vehicles fuel efficient. By manipulating the shape, they try to reach more fuel efficiency, because essentially friction is going to be affected by both the size and the shape of the object. Also, the speed of the object is going to affect the amount of air resistance. The faster it is, the more air resistance.